So in this lab, the main goal was to become familiar with the idea of charge using household objects like clear tape. Another goal was to understand the concept of amount of a sex charge, and the purpose of this lab was to determine approximately the the amount of excess charge there was in one piece of charge tape. Some background informations. So objects like clear tape can acquire an excess of negative charge or deficiency of negative charge, and so net positive charge when they are pulled apart or even just touched by other object. However, it's not easy to determine how much excess charge is on a charged piece like clear tape. So we know that the absolute value of the net total excess charge on the tape is between the charge of one electron and 1 mole of electron. So 1.6 times 10 to the negative 19 coulombs to 1 times 10 to the 5 coulombs. So before doing this lab, I expected that like bringing two U tapes close to each other, the tapes will repel because they have the same charge, and that's what happened was actually happened during the lab. So like they actually repel to each other when they were close to each other, and both U tapes stick to the table or book when they're close to them. That means that the table and book are like the opposite charge of the U tape. So here are some of the answers. So like if the U tape is positive charged, it will be attracted by the pen, which is negative charged. While if the U tape is negative charged, it will repel with the pen. And if the U tape has no charge, nothing's gonna happen. If the pen is pulled close to the U tape, and if rub the pen on here and put it close to the U tape is attracted, and so the U tape has a positive charge. Here to estimate the amount of excess charge in a U-tape, we need to find the electric force exerted on tape B. We know that the net force on tape B is equal to 0, so the gravitational force and the electric force are the same but opposite direction. And as you can see in the free body diagram. And so in order to determine the charge of tape B, we need to calculate the distance between tape B and tape A, and then use the distance to calculate the electric field. Here's some assumption. We assume that the charge on tape B is equal to the charge of tape A. And here's the mass of the tape I measured. Then, in order to calculate the charge on tape B, I put the equation of the electric force and the gravitational force equal to each other, since the net force is equal to 0, and I solve for QB. Here, in order to find the number of electrons of tape B, I divided the charge QB by the charge of one electron, and I got the value of 7.628 times 10 to the 9. And this is a deficiency of electrons because the tape is positively charged. In order to find the number of atoms on the surface of tape B, I calculate first the area of the tape and then the area of the atom. I assume that the atom has a shape of a sphere, and this was the formula to calculate the area of a sphere. And then I divide the area of the tape by the area of the atom, and I found that the number of atoms was 5.207 10 to 17. Then the ratio of the fission electrons to atoms was just like the value of 1.465 times 10 to the negative 8. Here in the coding, first I put the constants, then I create the function to calculate the electric field, the gravitational force, and find the charge QB in our case. Then I draw tape A and tape B as spheres instead of like rods or like tape, and then I calculate the gravitational force and the charge QB in our case. Then I find out also the charge of tape B and tape A and their locations location in order to calculate the electric field of tape A and tape B, and eventually I create the arrows of the electric field of tape A and tape B. And as we can see here, the blue sphere is the tape A, and the orange arrow is the electric field of tape A on tape B, and the red sphere is the tape B, and the green arrow is the electric field of tape B on tape A. And since they're positively charged, the direction of the electric field are opposite, and so the electric field are repelling each other. And here I wanted to point out that the charge that I got from the code is pretty much the same as the one that I got analytically. And for last questions, like if electron has positive charge and have positive charge and protons have negative charge, nothing will change. In fact, like electron will still attract protons, electron will repel with other electrons, and proton will repel with other protons. And if we touch the tape, which is that is charged, um, that's gonna make the tape become neutral. And so, even if an electric field exerted on the neutral tape, no electric force would be exerted on it.